This is 0620 Chemistry, Paper 4, variant 3, October-November 2019. Alright, question number 1. Atoms are made of smaller particles called electrons, neutrons, and protons. Complete the table. Now we're supposed to write the relative charge of electrons, which is -1. Alright, -1. And the charge of neutron is 0 because it has no charge, and relative mass is 1 unit. Similarly, proton also has a mass of 1 unit. Part B, the table gives information about atoms and ions A, B, and C. Alright, so we don't have only atoms but also ions, which means we are not going to be having equal number of protons and electrons in these three substances. Alright, part A, this is the symbol for aluminium, and since we can see there is no charge, now this means that the number of electrons and protons here is going to be equal since this is a neutral atom. So the number of electrons will be 13. Part B, now here we can see the charge here is +2, which means we have 2 extra protons. So since this is 12, we'll be having 10 electrons, and the number of neutrons will be the number of protons plus the number of electrons. The number of neutrons will be subtracting the atomic number from the mass number, which is 25 minus 12, and the number of neutrons here is 13. Right, part C. So we know the number of protons, which is also the atomic number, is 9. So the ion is going to have an atomic number of 9, and mass number is going to be 10 plus 9, which would be 19. In the periodic table, we have the fluorine atom, which has a mass number of 19 and atomic number is 9. But we're going to have to write this as fluoride ion since we have an extra electron here. So this would be... Alright, so we're going to have to put this dash on top of here and these number over here. Right, so this fluoride ion is going to have the mass number 19 and atomic number 9. Alright, question number 2. The table shows the melting points, boiling points, and electrical conductivities of 6 substances D, E, F, G, H, and I. Choose substances from the table which match the following descriptions. Each substance may be used once, more than once, or not at all. Which substance is a liquid at 25? Alright, now substance is a liquid at 25. This question gives us the hint that this substance is supposed to have a melting point lower than 25 degrees Celsius. So let's have a look over here. We see that the only 2 substances, F and I, are the substances which have a melting point lower than 25. Is a liquid at 25 degrees Celsius. Now this also tells us that the boiling point is supposed to be above 25 degrees Celsius so that it can stay in liquid form at 25. Now over here I has a boiling point much lower than 25, which means at 25 degrees Celsius it is going to be in gas form. So we're left with F. It has a boiling point above 25 and a melting point lower than 25. So the answer of part A is F. Part B. Which substance is a gas at 25 degrees Celsius? This is I. As we discussed earlier, it has a melting and boiling point both lower than 25 degrees Celsius. Which 3 substances contain simple molecules? Alright, simple molecules are going to be having low melting and boiling points. Alright, so let's have a look. And the simple molecules also gives us a hint that this compound or substance is not going to be a conductor, because We only have simple molecules in covalent compounds. We have ionic compounds, covalent compounds, and a third bonding with metals. But metals and ionic compounds both have high melting and boiling point, and they can also conduct electricity, whereas where metals can conduct electricity in both liquid and solid form, um, ionic compounds can only conduct electricity in molten form or in aqueous form. But covalent compounds cannot conduct electricity in either form. So we're going to have to look for three substances which have relatively low melting and boiling points, and also cannot conduct electricity in either forms. So we can take I for them, H also, since they have relatively lower melting and boiling points and they cannot conduct electricity either. And the third one is going to be F, since it has low melting and boiling point. We could have chosen D, but this has relatively higher melting and boiling points. Alright, so we have F, H, and I as the answers. Part D, which substance could be a metal? Give a reason for your answer. Alright, now we're supposed to be looking for a metal which can conduct electricity in both form, and it is also supposed to have high melting and boiling points, right? So this is going to be G. Alright, G, and it conducts electricity. In both solid and liquid form. Right. Part E, which substance has a macromolecular structure? Give two reasons for answer. Alright, macromolecular structure is found in covalent compounds. Now covalent compounds, they cannot conduct electricity, but when they have a macromolecular structure, they have high melting and boiling point. So we have this D over here which has high melting and boiling point but cannot conduct electricity. So the answer here is going to be D. Reason 1 is that it is a non-conductor, and reason 2 is that it has high melting and boiling points. Alright, part F, which substance is an ionic solid? Give one reason for an answer. So we know that ionic compounds can only conduct electricity when they are in molten or aqueous form. So let's look out for a substance which has those particular features. Alright, now this one, E, has these features. It can conduct electricity when in liquid form, however not when it is in solid form. And it also has high melting and boiling points. So our answer is E. And the reason is that it conducts electricity in liquid form. Question number 3A. Name the ore of aluminium which mainly consists of aluminium oxide. Right, so this is bauxite. Part B. Aluminium is produced by the electrolysis of aluminium oxide dissolved in molten cryolite. 1. Give two reasons why the electrolysis is done using a molten mixture of aluminium oxide and cryolite instead of molten aluminium oxide only. Alright, so we use cryolite because it lowers the melting point of aluminium oxide, and it also increases electrical conductivity or improves electrical conductivity. Part 2. Write ionic half equations for the reactions occurring at the electrodes. Alright, so for the positive electrode, we are supposed to be having a negative ion since opposite charges attract. In this case, we have aluminium ion and oxide ion, both from the compound of aluminium oxide, and since aluminium is a metal, it is going to have a positive charge. So it would be attracted toward the negative electrode, and oxide ion, which is negative ion, will be attracted towards the positive electrodes. Alright, so on the positive electrode, we're going to be having the oxide ion. Now, each oxide ion has a charge of 2 minus, since in its outer shell it has 2 extra electrons. But whenever we write half equations, we're supposed to write a 2 over here. And the reason for this is that when the oxygen atom itself is deposited, we always have it in the form of a diatomic molecule. It does not occur as a single atom. So we have this 2 over here, 2 minus for each of the single ions, and another this 2 on the left hand side denotes that there are 2 oxide ions. Now since there are 2 oxide ions with each one having 2 electrons, 2 extra electrons, we're supposed to subtract 2 from each, and hence in the result we'll be having 4 extra electrons removed with a diatomic molecule of oxygen. Alright, moving on to the next electrode, which is the negative one, or the cathode. It is going to be having aluminium ion of 3 plus charge, since it has 3 more protons than 3 electrons. Alright, so we need to add 3 electrons to this ion so that this 3 plus charge will be cancelled. So we add 3 electrons and then we get the atom aluminium itself. Alright, that's it. Part 2. The anodes are made of carbon and have to be replaced regularly. Explain why carbon anodes have to be replaced regularly. Right, so anode is the positive electrode, and this is where oxygen is deposited. Now this oxygen reacts with the carbon in this anode and forms carbon dioxide, and this is the reason the electrode is dissolved, and so it can no longer perform. Right, so oxygen reacts with carbon in anode, forming carbon dioxide. C. Part 1. The positions of some common metals in the reactivity series are shown from least reactive, copper, moving on to more reactive atoms, copper, aluminium, and magnesium, or more reactive elements. C. Part 1. When magnesium is placed in aqueous copper sulfate, a displacement reaction occurs immediately. Now, as we can see over here, magnesium is far more reactive than copper. This is why it replaces copper in this compound of copper sulfate. Write an ionic equation for the reaction and include the state symbols. Alright, so in ionic equations, we're supposed to start with the ion. Now in this case, we'll be having the ion of the element which is going to be replaced, and we know that copper is going to be replaced over here. So we're supposed to write the ion for copper. It has a charge of 2 plus. As you can see over here, it is copper 2 sulfate, and ions always exist in the form of aqueous. Right, now this is going to be replaced by magnesium. Initially, magnesium is going to be in solid form, and as a result, magnesium is going to displace copper over here and form magnesium sulfate. So magnesium is going to become the ion over here in aqueous form, and we'll be having copper as metal in solid form. Alright. State 2 observations you would make when magnesium is placed in aqueous copper sulfate. Alright, so when magnesium displaces copper sulfate, the solution is no longer copper sulfate but magnesium sulfate. And since the solution copper sulfate is blue in color, the blue color fades out. So this can be one of the observations. Blue color fades. And now we're going to be having copper alone as a metal when it's displaced by magnesium, so a brown solid forms, which is the metal itself. When aluminium foil is added to aqueous copper 2 sulfate, no immediate reaction occurs. Explain why. Alright, so aluminium is a highly reactive metal, and once it is exposed to air, it reacts with oxygen, and this results in a formation of aluminium oxide on the surface of aluminium. Now this is a layer which prevents aluminium beneath the layer from reacting with any surface. So it is due to this protective layer that aluminium does not react with any other substance. So due to the protective layer on its surface. Part D. Aluminium powder reacts with iron 3 oxide to produce aluminium oxide and iron. Write a chemical equation for this reaction. Alright, so we have aluminium with iron oxide, Fe2O3. Alright, and this is going to be giving us, now iron is going to be displaced by aluminium, so we'll be having aluminium oxide instead of iron oxide. We'll be having the same formula since the charges of aluminium and iron 3 are the same, and we'll also be having aluminium metal as in the metal form. Alright, now here we have two iron atoms, so let's equate it over here as well by writing two atoms of iron, and since there are two atoms of aluminium over here, let's equate it on this side as well. And the number of oxygen atoms is same in both of these cases. Alright, question number 4, part A. This question is about phosphorus and compounds of phosphorus. A phosphorus molecule contains 4 phosphorus atoms only. What is the formula of phosphorus molecule? Well, this one's quite easy. P and a small 4, which is alright. So P with a small 4 at the bottom. Okay, moving on to the next question. B, part 1. The phosphorus reacts with chlorine gas to produce phosphorus 3 chloride. Write a chemical equation for the reaction between phosphorus and chlorine to produce phosphorus chloride. Alright, so we'll be having phosphorus, very small 4 at the bottom, with chlorine, which is a diatomic molecule, and this is going to be forming phosphorus chloride, right? PCl3, like the formula in the question. Now we're supposed to be balancing this. We have 4 atoms of phosphorus over here, so let's equate it over here as well. Now this gives us 3 atoms of chlorine. 12 atoms of chlorine, since 4 3s are 12, and by writing it 6 over here, we'll be having 12 atoms of chlorine over here as well. Alright, part 2. Complete the dot and cross diagram to show the electron arrangement in a molecule of phosphorus 3 chloride. Show outer electrons only. Alright, so phosphorus has atomic number 31. It is in group 5, which means it has 5 electrons in its outer shells. Okay, and chlorine is in group 7, which means it has 7 electrons in its outer shell. So each chlorine atom needs 1 electron to have 8 electrons in its outer shell. Now phosphorus has 5. It needs 3 electrons. One phosphorus atom is going to share 1 electron with each of these 3 chlorine atoms. This means these chlorine atoms will be having 8 electrons as well as this phosphorus atom. Right, I'm going to be using dots for phosphorus and cross for chlorine atoms. So it's going to be sharing 1 with each chlorine atom. Right, we have a phosphorus electron and a chlorine electron. Again, over here we have a phosphorus and a chlorine electron. Same over here. Alright, now since phosphorus has 5, 3 of them are already over here, and we're remaining are 2. Now let's count these. These are 2, 4, 6, and 8. So phosphorus has completed its outer shell, and similarly chlorine had 3. And now, 7 electrons in its outer shell, which is now complete since it's sharing 1 electron with phosphorus atom. Okay, so moving on to part C, gaseous phosphorus 3 chloride reacts with gaseous chlorine to form gaseous phosphorus 5 chloride. Alright, so we have the equation over here. The chemical equation for this reaction can be represented as shown. Use the bond energies in the table to calculate the energy change of the reaction. Alright, so for calculating the energy change, we're supposed to be adding all of the bond energies on the reactant side, and then from the result we are supposed to be subtracting the sum of bond energies of the product side. To start off, we're going to be having to calculate energy needed to break bonds. Now in the reactant sides, what is happening is we're going to be breaking bonds, which needs energy. So let's calculate the energy which is needed over here. So we have 3 bonds between phosphorus and chlorine atoms. Alright, so this is the energy for each of one of these bonds, and we have only 1 bond between 2 chlorine atoms. Now we're supposed to add both of the bond energies of these substances. So the total energy for the first compound is going to be 3 times 326, since we have 3 bonds between phosphorus and chlorine, which is 978. And now we're supposed to add the bond energy of the chlorine molecule, which is 243. So this gives us a total of 1221. Now this is the energy we need to break all of these 4 bonds. And then we also need energy to form these bonds. Now as we can see over here, all of these bonds are same, which is 5 bonds between phosphorus and chlorine atoms. So to calculate this, we're going to have to multiply 5 with 326. Which gives us 1630 kilojoules. Right, let's write it over here. You're supposed to write it over here since we're given the space. Now, energy change. We're supposed to, as we mentioned earlier, we're supposed to be subtracting the energy which is released on the product side from the energy needed on the reactant side. So 1221 minus 1630. This leaves us with negative 409 kilojoules per moles. Now mentioning the negative sign over here is quite important, since this tells us whether the reaction is exothermic or endothermic. Whenever we have a negative sign in the result, this means that the overall reaction is exothermic. And whenever we have a positive sign over here, that means the reaction is endothermic. So part 2, Deduce whether the energy change for the reaction is exothermic or endothermic. Explain your answer. So this is an exothermic reaction since overall energy change is negative. Alright. Part D. Under certain conditions, the reaction reaches equilibrium. State and explain the effect, if any, on the position of equilibrium if the pressure is increased. All other conditions are unchanged. Alright, so whenever pressure is increased on an equilibrium, the side which has the least number of molecules is always favored. Now the reason behind this is that, let's suppose we have, alright, we already have this example over here. We have two compounds on the reactant side of phosphorus chloride and chlorine diatomic molecule. Whenever we increase the pressure, the collision rate of collision over here is going to be increasing. It would also increase over here, but since here there is only one compound, the reaction number of total reactions would be less than over here. So overall, the number of collisions and hence the forward reaction would be faster. So the right hand side, the product side of this reaction would be favored. So whenever we apply pressure on an equilibrium, the side with the least number of compounds or the least number of molecules is always favored, because the opposite side is going to be having the most number of collisions. Alright, so we have the answer that equilibrium shifts to right because it has the least number of molecules on its sides. Okay, part E. Phosphine is produced by the reaction between water and calcium phosphide. Balance the chemical equation for this reaction. Okay, so we have all of these compounds. Now, as we can see over here, we are supposed to be having only 3 atoms of calcium. Now this is how we're going to be balancing the number of atoms of calcium over here. Right, 3. Now this also tells us that we're supposed to be having 3 oxygen atoms, and alright, so let's write 3 over here first. No, but wait, we have to equate hydrogen first. No, we have 6 atoms of hydrogen over here, since we multiply 3 with 2, and this 2 or 6, when we multiply 3 with 2, we have 6 over here. Now this tells us we have 6 oxygen and 6 hydrogen atoms. So we'll be balancing 6 for oxygen on the reactant side. Since we don't have any other oxygen atom over here, that means the total number of atoms of oxygen can be calculated over here. Now we have 6 into 2, which means 12 hydrogen atoms on the reactant side. So we have 6 over here. Now we are only left with 6 remaining hydrogen atoms. Now when we write 2 over here, this will give us another 6 hydrogen, which means a total of 12 hydrogen atoms. Alright, moving on to part F. The phosphonium ion is similar to ammonium ion. State the formula of ammonium ion. This is quite simple, since the question itself says we have the same ion. So ammonium ion is NH4 plus, just like the phosphonium ion. Suggest the formula of phosphonium iodide. So iodide ion has a -1 charge, which means a single ion of phosphonium can cancel out the charge of a single ion of iodide ion. which means we only have a single ion of both of these in the compound. Part G. Calcium phosphate contains the phosphate ion PO43 minus. What is the formula of calcium phosphate? Alright, so whenever we're supposed to be writing formulas of any compound, we're supposed to follow the following steps. Write both of the ions or compounds or elements of the compound which you are dealing with. In this case, we have the phosphate ion and the calcium ion. Now, calcium over here has a charge of 2 and phosphate has a charge of 3, or you can say the valency. Now, cross both of these, which means we'll be having 3 atoms of calcium. We write it this way, 3 atoms of calcium, and we'll be having 2 ions of phosphate. So we write the ion and then we put it in brackets with 2. Okay, that's it. Phosphorus forms another compound with hydrogen with the following composition of mass: phosphorus 93.94 and hydrogen 6.04. Calculate the empirical formula. Alright, so first of all, we're supposed to be calculating the mass of phosphorus and hydrogen. So for calculating the mass, we need to calculate it by using the formula mass over molar mass. In this case, we're going to be using this percentage instead of the mass. So we have for phosphorus, let's start off with writing the headings first, and we have 93.94 divided by the molar mass of phosphorus is 31, which gives us a mass of 3.03. Now let's repeat the following steps with the same steps with hydrogen. This is 6.06 divided by 1, which gives us 6.06. Now we're supposed to be calculating the ratio of both of these 3 moles, 3.03 and 6.06, which means we're supposed to divide both of these values with the least value. So dividing both of these by 3.03 gives us 1:2. This is the ratio of phosphorus to hydrogen atoms, which means we have the formula pH with a small 2 at the bottom. That's it. That's the empirical formula. The compound has a relative molecular mass of 66. Deduce the molecular formula of the compound. Alright, so in order for us to calculate the molecular formula of the compound, first off we need to have the MR of the compound itself, pH2. So the MR is 31, that is the molar mass of phosphorus, with 2, which is the molecular mass of hydrogen. So 2 plus 31 gives us 33. Now we're supposed to divide 66 with 33. Alright, so 66 divided by the MR of the compound itself, which is 33, and this gives us 2. Now we're supposed to multiply this 2 with the empirical formula that we had. So 2 with 1 of phosphorus gives us 2 atoms of phosphorus, and 2 with 2 atoms of hydrogen gives us 4 atoms of hydrogen. In short, we're supposed to be multiplying this with the number of atoms. So 2 ones are 2 and 2 twos are 4, which gives us P2H4. That's it. Alright, question number 5. Nitrates such as ammonium nitrate are used as fertilizers. The final stage in the production of ammonium nitrate is shown in the equation. Calculate the maximum mass of ammonium nitrate that can be produced from 820 grams of calcium nitrate using the following steps. The relative formula mass of calcium nitrate is 164. calculate the number of moles. Right, so number of moles is equal to mass over molar mass. The mass we have over here is 820 divided by the molar mass, which is 164, and this gives us the answer as 5 moles. So we'll be writing 5 over here, and then we have deduced the number of moles of ammonium nitrate produced. Alright, whenever you find this term deduce, we always have to use the equation for this. Deduce the number of moles of ammonium nitrate produced. Alright, in the question you'll see that 1 mole of calcium nitrate gives us 2 moles of ammonium nitrate, which means when for each 1 mole of calcium nitrate we'll be having the double amount for ammonium nitrate. So 5 into 2, that is the double amount of 5, is 10 moles, or in case 5 2s are 10. We can always cross multiply. Right, calculate the MR of ammonium nitrate. Alright, so we add the molar mass of all of these atoms. We have 2 atoms of nitrogen over here, so we'll be multiplying 2 with the molar mass of nitrogen. Right, so 2 times 14, which is the molar mass of nitrogen, and then we add the MR of hydrogen. Since we have 4 into 1, the same as 4, and then we have 3 atoms of oxygen, so 3 times the molar mass of oxygen, which is 16, and we get the result as 80. Calculate the maximum mass of ammonium nitrate produced. Alright, so mass is moles into molar mass. Now we have the moles of ammonium nitrate over here and the molar mass over here. So 8, I'm going to be multiplying 8 with 10, which gives us the answer of 800 moles, or sorry, 800 grams.